Good day, students. Welcome to math.serve.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 1 to 5 of the January 2019 Algebra 2 New York Regents exam. For access to the remainder of this review series, just take a look at the link in the description. And don't forget to like and subscribe to this video for updates to the remainder of this review series. Alright, let's take a look at question number 1. Question 1 reads, suppose two sets of test scores have the same mean but different standard deviations, sigma 1 and sigma 2, with sigma 2 greater than sigma 1. Which statement best describes the variability of these data sets? So in question number 1, we've been assessed as to how to draw a connection between the standard deviation of two data sets, the concept of mean, and also the term of the size of variability. Alrighty, so before we answer this question, let's go ahead and do a real quick refresher on the measures of variability that we have in statistics. Okay, alright, so let's review that real quick. It's important that you know all of them. So recall, concerning the measures of variability, you're going to remember that there are 4 of them, okay? The first one is the range. So if you're thinking about a data set that's comprised of scores, for example, the range would basically be the highest score minus the lowest score. Okay, so highest minus lowest. That's the range of the data set. So this is one measure of variability. Another measure of variability is the interquartile range. Okay, so the next one is the interquartile range. This is another measure of variability. So if you want to calculate the interquartile range, all you just simply do is subtract the first quartile from the third quartile, okay? Or think about the difference between the 75th and the 25th percentiles. If you compute that difference, that will give you the interquartile range. All right. The third measure of variability is the variance. All right. And the variance is just simply the degree of spread of the scores in this context. So degree of spread of the scores. And then lastly, we have the standard deviation. Standard deviation. The standard deviation is similar to the variance, but the standard deviation refers to the spread of the scores from the mean. Okay, so that's another measure of variability. So it's the spread of the scores from the mean. So this basically helps us to answer the question that we're going to be working on. Alright, so another point to keep in mind, something to note, is the relationship between the standard deviation and the magnitude of the variability. So something to note concerning the standard deviation, one of the 4 measures of variability that we have, and the variability of the data set. One thing you want to note is that there is a direct variation between these two. Okay, they vary directly with each other. So what does that mean? So the standard deviation varies directly with what? Varies directly with the size of the variability. Okay, so all that basically means is that if you have a greater standard deviation value, so if you have a greater sigma value, that automatically implies that you're going to have a greater variability. That's what direct variation means. And then the reverse is also the case. If you have a smaller standard deviation, smaller sigma value, you're going to have smaller variability. That's because the spread of the data set from the mean is smaller. All right? So in this particular case, we know that the standard deviation of data set 2 is greater than the standard deviation of data set 1. Okay, so what does that automatically tell us concerning concerning how their variabilities compare with each other? Since we have the mean of both of them are exactly the same, since if the standard deviation of dataset 2 is greater than the standard deviation of dataset 1, it automatically implies that dataset 2 will have a greater variability compared to dataset 1. Okay, so let's go ahead and write it down. Um, since the standard deviation of dataset 2 is greater than the standard deviation of dataset 1, that basically means that dataset 2 will have a greater variability. Okay, remember, the greater the standard deviation, the greater the variability. So since dataset 2 has a greater standard deviation, it automatically follows that it's going to have a greater variability compared to dataset 1 because they have exactly the same mean. Alrighty? So if you take a look at the options that we have right here, option 1 says dataset 1 has greater variability. That's incorrect because if it did, then we'll have a scenario where sigma 1 will be greater than sigma 2, but that's not the case. Dataset 2 has the greater variability. Absolutely. This is automatically true because dataset 2 has a greater standard deviation. All right, let's take a look at question number 2. In question 2, you're being assessed on how to carry out transformations on logarithmic functions. Okay. Before we take a look at this problem, well, let's read it first. It says, number 2, if f of x equals log base 3 of x and g of x is the image of f of x after a translation 5 units to the left, which equation represents g of x? Okay, so let's review our transformation formulas real quick, and then we're going to adapt it to this particular problem. All right, so we need to remember the following concerning transformations. All right, so first of all, you need to know what happens when you compose a function with x plus h. All right, f of x plus h means that you have to shift the function. You're going to shift it in the direction of the x. But whenever a number is grouped with the x, you do the opposite. Okay, so x plus h basically means that you're going to shift h units to, guess what, the left. All right, if you have the function composed with x minus h, remember when it's grouped with the x, you do the opposite. X minus h means that you're going to shift h units, guess what, to the right. It's counterintuitive, right? But when you add a value to the function f of x plus k, this one is intuitive. When you add a function to, a number or constant to a function, that's a shift in the y direction. F of x plus k is a shift k units, guess where? Upwards. Okay, unlike the x where positive is to the left and negative is to the right, for the k direction or the y direction, positive it means up, and negative f of x minus k means down. So function minus k is going to cause the function to shift k units down. Alrighty. Now, what do we have in this particular case? We have a translation 5 units to the left. All right, so let's transform that into mathematical format. A translation 5 units to the left is going to have what impact on the function? It's going to be f of, now since we're moving in the horizontal direction, we're going to group it with the x. So which one is to the left? This guy right here, right? This is the one we're looking at. A translation 5 units to the left is the function composed with x plus 5. Okay? Alright, so what is f of x? F of x is log base 3 of x. Now we want to find g of x. G of x is what you get when you shift the function 5 units to the left, or basically f of x plus 5. Now how do we compose this original function f of x, which is log base 3 of x, with x plus 5? All you simply do is you take out the x and guess what? Replace it or substitute x plus 5 for the x. So you have log of quantity x plus 5 instead of x base 3. Alright? So our transformed function g of x, which is equal to log base 3 of x plus 5, is the image that you get when you shift the function f of x, which is log base 3 of x, 5 units to the left. Okay? So this is basically how you transform functions. Alright, let's take a look at question 3. Question 3 is assessing your ability to factor higher degree polynomials using the factoring by grouping method. Okay? Alright, question 3 reads, when factoring to reveal the roots of the equation x to the third plus 2x squared minus 9x minus 18 equals 0, which equation can be used? Alright, so what we're going to do is we're going to proceed to factor this cubic with 4 terms in 2 different ways and see which one matches the steps, the options that we have here. Alright, so we'll get started by factoring this cubic with 4 terms just the way it is first, and then we will interchange the middle terms and factor it out again and see what we get. Alright, so x to the third plus 2x squared minus 9x minus 18 equals 0. Okay, so we have 4 terms here. If we want to factor by grouping, what we're going to do is we're going to divide it right down the center. Okay, so we're going to form a partition right down the center like that. So factoring by grouping means we have 2 terms in the left side of the partition that forms a group, and then the last 2 to the right forms another group. Alright, so just to give you a visual indication as to what I'm doing, let's use a parenthesis to help us out here. So for the first 2, we have x to the third plus 2x squared, and then I bring down this minus, and then for the next 2 I have quantity 9x. Now freeze for a second. If you put a parenthesis there, it is as though I have factored out the minus out of these 2 quantities. And guess what happens? When you factor out a minus, signs change. This was negative 9x before, now it's positive 9x. This minus 18 becomes positive 18. Alright, so anytime you have a negative in the center when you're factoring by grouping, you want to proceed with caution. Make sure that you invert the signs when you pull out a minus. Alrighty? Okay. So we're going to go ahead and factor out the GCF. Now something to remember concerning factoring out the GCF. You want to remember that when you factor out a GCF, what is it you're doing in essence? When you factor out a GCF, what you're doing is you are dividing out that GCF. You're dividing by that GCF. That's what factorization is. So just to illustrate, in this particular case, we factored out a minus. So what we were doing in essence is that we were dividing these 2 terms by negative. That's why these signs change. Alright, because when you divide by negative or multiply by negative, the sign changes to the opposite. Alrighty? Okay, now let's go ahead and factor. From the first two, we have x to the third and 2x squared. Okay, so let's put a 1 here. Alright, so we're going to pull out our common factors, okay? So for x to the third and x squared, what is the greatest common factor there? You look at the powers, whichever one is smaller, that's going to be the greatest common factor. Alright, and then for 1 and 2, you can just pull out a 1 or you just leave it alone. Alright, so let's go ahead and pull out the GCF for x to the third and x squared. The smaller of the two is 2, so we're going to factor out x squared. So what does it mean to factor out x squared? To factor out x squared means we're going to divide these two by x squared. When you divide x to the third by x squared, what happens is that the power is going to reduce by the power of the term you factored out. So since you factor out x squared, this will be reduced by 2 and is going to be left with 1. And then this one is going to be reduced by 2, so the power is going to be 0. And anything raised to the 0th power other than 0 is 1. So this x squared becomes 1. The entire x squared is divided out. Okay? And then as for the coefficients, you can put a 1 there, but it doesn't really matter if you do or don't. Okay, so what do we have left? X to the third has lost 2 of its powers, so it's going to be left with x. So we have x plus, and then we're just left with 2 here, then minus. Now let's look at 9x and 18. Is there a common factor that we can pull out? What is the biggest number that goes into 9 and 18? 9, right? So we pull out a 9, factor out a 9. So we're dividing by 9. That's what factorization is. So 9 goes here 1, and then 9 goes into 18, 2. Okay, and then we're left with negative 9, and we have x plus 2 equals 0. Okay? And then just to make sure we did it correctly, you want to take a look at the terms in the parentheses. Are they identical? If they're identical, that's an indication that your factoring by grouping steps were correct, and that's the case here. Okay, so we factored by grouping. We're not done yet, but let's check and see if we have a match at this time. X squared times x plus 2 minus 9 times x plus 2. That matches with option number 1. So this can be used to reveal the roots of the equation. If we complete the factorization process, this is how we do it. What we do is we take the terms that have identical values, these two identical quantities right here, we factor them out as though we're dividing out. So we're going to have x plus 2 factored out, and then x squared and negative 9. Guess what we do with those two terms left behind? Those two terms left behind are grouped together in their own nice little parentheses. X plus 2 times x squared minus 9. Uh-oh, we have a problem here. If you look at option 3, it says x minus 2 x squared minus 9. There's a disparity with the signs here. So that automatically tells us that option 3 is not an equation that can be used. If you take a look at option 2, what happened is that the middle terms were interchanged before factoring by grouping. Okay? It doesn't change the factored form, the final factored form. It just reverses the product of the quantities. So let's go ahead and do that. I'm going to rewrite the problem, but I'm going to interchange the middle terms. Alright? So it's going to be x to the third plus 2x, no, not 2x squared, I'm covering the same thing. X to the third minus 9x plus 2x squared minus 18 equals 0. Okay, so we're going to break it down the center, and we're going to factor by grouping. Alright, so for the first two terms, well, let's group them again visually so we can see exactly what's going on. So we have x to the third minus 9x grouped together plus 2x squared. Now you remember previously when we put the parentheses after the minus, signs were changing all over the place. But in this situation that we have here, do we reverse signs? The answer is no. It's only when you factor out a negative that signs change. Okay, so this minus will remain minus like that. Okay, so now we're going to proceed to pull out GCFs. X to the third and 9x. The power for x is just 1. So remember, when you're factoring out degree terms, you take the smaller power. That's going to be the GCF. So x to the third and x to the 1. The 1 has a smaller power, so we factor out x to the first power. Okay? And then we're going to subtract this power from these two powers. What happens to x to the third is that the power goes down by 1 to become 2. So we're left with x squared. So let me just illustrate to you what I'm talking about, the division process. X to the third divided by x. What's happening is that if we break it down, x times x over x to the 1, this x right here just takes out one of the factors. Okay, so whatever the power of the denominator is, it takes off that much power from the numerator, or the degree that you're dividing by. So that's why you end up with x squared. All right, so that's why we have this right here. But when you have x and x, identical powers, guess what? They take each other out completely. And then you are left with x squared minus 9. Okay? Now, on the right side of the partition, 2 and 18. What is the biggest number that goes into 2 and 18? The answer is 2. So you factor out 2. And then now we're going to divide by 2. Okay? So 2 goes into 1. And 2 goes into 18 9 times. And we are left with a 1x squared minus 9 equals 0. Alrighty, so here we freeze and check again and ask ourselves, the quantities in the parentheses, are they identical? They are, so that shows that our factorization process is accurate. Now let's see if we have a match here. X times x squared minus 9 plus 2 times x squared minus 9. Option number 2 is absolutely correct also. It can be used to reveal the roots of this equation right here. Alright, so the answer to this question is option number 1. Okay? Alright, so what we're going to do is we're just going to finish the problem off. The question doesn't ask us to do it, but I think it's important that you know how to solve equations of higher roots. Okay, so if we want to factor this one, we just factor out the x squared minus 9, and we're left with x plus 2. Since multiplication commutes, this equation is exactly equal to this equation. The factors are written in reverse order, but since multiplication commutes, it doesn't matter the order of the product of the factors. Alright? So next we use the zero product property and set both factors equal to 0, and then solve for the roots. So here we just add 9 to both sides, equal 9, and then we take the square root, and then that gives us x equals plus or minus 3. Remember, anytime you take the square root of a square, you have to introduce a plus or minus sign. And then over here, you subtract 2 from both sides, x equals negative 2. And your roots are, in roster form for sets, negative 3, negative 2, and positive 3. And that, ladies and gentlemen, are the roots for question number 3. Alright, let's take a look at question number 4. In question 4, you've been assessed in how to find the nth term of a geometric sequence. Okay? The question reads, when a ball bounces, the height of consecutive bounces is a geometric sequence. The height of the first bounce is 121 centimeters, and the height of the third bounce is 64 centimeters. To the nearest centimeter, what is the height of the fifth bounce? Okay, so what do we have here? We have a geometric sequence. Let's go ahead and write it down. We have 121 is the first value. Second value is not known. The third value is 64. And then the fourth value is unknown. We're asked to find the fifth value. Okay, so let's assign them variables. A1 represents the first term, A2 the second term, A3 is the third term, A4 is the fourth term, A5 is the fifth term. Alrighty, so just remember that the index represents the term. To solve this problem, we need to remember our formula for the nth term of a geometric series. So nth term of a geometric sequence, sorry. Alright, so the formula for the nth term of a geometric sequence, an is given by a1 times the common ratio raised to the n minus 1. Alrighty, so that's the formula for the nth term of the geometric sequence. Now, with this formula, if you're given any two components, you can find the third one. Okay, so for example, if you're given a particular term, the first term, you can find the common ratio. If you're given the common ratio in the first term, you can find the third term. Alright? And also, yeah, so that's that. In this particular case, we are going to be using this formula twice. Alright, because we're asked to find the fifth term. What we're going to do first is we're going to use the terms that we're given, the first and the third terms, to find the common ratio. And then after we find a common ratio, we use the formula again to find the fifth term. Okay, so step one is to find R. What is R? The common ratio. So, we need just one unknown in the formula. The formula is an equals a1 r to the n minus 1. Okay, let's write down what we know and what we need. We know that for n equals 3, and let's say n equals 3 because we're working with the third term here. And then a1, the first term is 121. The third term, an, is going to be a3. a3 is 64. And the common ratio is what we are looking for. Alright, so plug all this into the equation that we have right here, and then we can determine what the common ratio is. Alright, so plug it into the equation. What do we have? So, plug into the equation, we have an, which is a364, equals a1, the first term, 121, times the common ratio, r, raised to the n minus 1. So n is 3, so that's going to be 3 minus 1. Alright, so 64 is equal to 121 raised to r times r raised to the second power. Now we're going to divide both sides by 121, 121, 121. And what does that yield? We have r squared is equal to 64 over 121. Let's write that again. 64 over 121. Okay, r squared equals 64 over 121. So what is r going to be? To get r by itself, we're simply going to take the square root. Okay, so to take the square root, root this, root that, numerator and denominator. And this basically helps us to see that the common ratio r is 8 over 11. Perfect. Now that we have the common ratio, we can now move on to the second step, which is to find the fifth term using that common ratio. Okay, so now what we're going to do, our goal is to find a5, the fifth term. Okay, let's do it. So in this new situation here, since we're working with the fifth term, a1 is still the same, 121. N is the number of terms we're dealing with, which is 5. The common ratio is what we just found, which is 8 over 11. And a5 is what we are looking for. Okay? Alright, so what we're going to do is we're going to plug these into the equation, the formula. And we have a5, what we're looking for. You know what? Let's write the formula again first so we don't mess this up. An is equal to a1 times r to the n minus 1. Alright, so a5 is equal to a1, which is 121, times the common ratio, 8 over 11, raised to the n minus 1 is 5 minus 1. Okay, so we're going to use our calculators for this since we're asked to find the approximate value. So 121 times 8 over 11 raised to the fourth power. Okay, let's plug that into our calculator and we're going to round it to the nearest centimeter or the first decimal to the ones place. All right, I'm going to be using the TI-84 to enter this expression. So we have 121 times 8 divided by 11, 8 divided by 11 raised to the fourth power. Enter 33.8512397. If we round it to the nearest centimeter, it's going to be 34. Okay, because we're going to round up because the number in the tenths place is 5 or greater, so you round up. Answer to question 4 is option number 2. So this is basically how you use the nth term formula of a geometric sequence to find the common ratio, and then use that common ratio on the first term to generate another term of the sequence. All right, let's take a look at question number 5. In question 5, we were going to be going over how to use the quadratic equation, the quadratic formula to solve quadratic equations. So it says the solutions to the equation 5x squared minus 2x plus 13 equals 9 are. So before we get started, let's go ahead and try and see if we can solve this by factoring first. If you want to solve this by factoring, what you're going to find out is that you're going to run into complications because if you look at the options right here, there are square roots involved. So that should automatically tell you that you cannot solve this equation by factoring. Okay? Alright. Now, one thing you want to keep in mind is the first step if you want to solve quadratics by factoring or using the quadratic formula. The first step has to do with the form. Okay, so something that you really want to note is that you have to place the so when solving quadratic quadratic equations by factoring or the quadratic formula, there is something you must do first, which is very important. What is that? You have to place the equation in standard form. Okay, or write the equation in standard form first. Standard form. What on earth is standard form? Well, standard form is the form ax squared plus bx plus c equals 0. Okay, you put all the terms to the left side, simplify completely, and write the terms in descending order of degree equals 0. So you have to do that first, or else you're going to totally ruin the problem. Okay, so as you can see in this particular equation that we have here, this equation is not in standard form. The question is, do you see why? So take a look at this and take a look at the standard form. It is not in standard form because it has to be equal to 0. Everything on the left side is fine, but there's a constant on the right side which is not acceptable. So what we have to do first is rectify that problem. When you subtract 9 from the right side, it combines with positive 9 and it is gone. Okay? So with that step, adding 9 to both sides, we are going to end up with 5x squared minus 2x plus 13 minus 9 is positive 4. Bam! Now, ladies and gentlemen, we have accomplished the standard form. Okay, we have changed the original equation into the standard form. Alright, so we're going to use the quadratic formula to solve this. But remember, I told you earlier that this cannot be factored. Let me just show that to you real quick. So let's say I wanted to factor this using the AC method. AC is going to be 20 and B is negative 2. So you think to yourself, what combination of two numbers multiply to give you 20 and add to give you 2? Add or subtract to give you negative 2. Okay? So let's do it. So what number is multiplied to give you 20? 1 times 20 gives you 20. 2 times 10 gives you 20. 3 doesn't go 4. 4 times 5 gives you 20. We have a complete loop. Now, you look at these pairs and ask yourself, are there any pairs that add or subtract to give you negative 2? 1, 2 gives you 21 and 19. 2, 10 gives you 12 or 8. 4, 5 gives you 1 or 9. None of them work. This equation is prime. That is why we have to resort to the use of the quadratic formula. Okay, and as indicated before, when you see radicals or imaginary numbers, that automatically tells you that this equation is prime. It is not going to be factorable. Whenever you have rational roots, basically, you know what rational numbers are, whole numbers or the quotient of integers and their quotients, then you know for a certainty that you can factor. In this particular case, we can see that it's not going to be factorable, and then our work here confirms that. So now that we have shown that factorization doesn't work, then we're going to use the quadratic formula, which always works. So what is the quadratic formula? Let's refresh our memory on that. Remember what the quadratic formula is. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so that's the quadratic formula. So the first step in using the quadratic formula involves specifying what your a, b, and c values are. A is the coefficient of the leading term, which is 5. B is the coefficient of the first degree term, which is negative 2. Don't forget the sign. And C is a constant, which is 4. Okay, so basically this is A, B, C. Bam. So now that we know A, B, C, we're going to substitute these values into the quadratic formula that we have written over here. So that's going to give us x equals negative, now b is negative, so minus 2 plus or minus the square root of b squared, which is negative 2 squared, minus 4ac and then we are going to divide that by 2a. Okay, so divided by 2a. So 2 times 5, that's 2a. Alright, now let's proceed to simplify this using the order of operations. We're going to PEMDAS this real quick. Minus minus, this is going to be positive 2 plus or minus the square root of negative 2 squared. When you square a negative number, the minuses pair up and become positive, so that's positive 4 minus 4 times 5 is 20. 20 times 4 is 80. And then this entire thing divided by 2a, which is 10. 2 times 5. Alright, let's keep on simplifying. Using the order of operations, this quantity underneath the radical can be viewed as something grouped in parentheses. So we'll simplify that next. So that gives us 2 plus or minus the square root of 80. 4 minus 80 is negative 76 divided by 10. Alright, so we have a negative radical here. So the question is, can we simplify this? Well, let's see. What we're going to do is we're going to proceed to extract this radical term, put it to the side here for simplification if possible. Alright, so square root of negative 676. First thing you want to note is when you take the square root of a negative number, that negative comes out as the letter I. Alright, because the square root of negative 1 is I. So this comes out as an I. And let's break this down and see if we have identical factors that we can take out from here. So, let's see. What goes into 76? Since it's even, 2 goes. 2 goes into 76 38 times. 2 goes into 73, okay. And then take out another 2 because it's even. 2 goes into 38. 19 times. 2 goes into 3, 1, carry 1, 2 goes into 18, 9. And this is prime. Oh, nice. We have identical factors. So what is the square root of 2 times 2? Square root of 2 times 2 is the square root of 4. So guess what? The square root of 2 times 2 comes out as the square root of 4, which is 2. Okay? So the simplified form of negative 76 is 2, and then the I will multiply them by each other. And then this 19 right here doesn't have a partner to break out with, so it stays behind as a radicand. Alright, so it's 2I root 19. Alright, let's put that back into the equation. We are going to have x equals 2 plus or minus 2I root 19. And then we can proceed to split out the denominator. Okay, so this over 10 and this over 10. And then we can reduce further. 2 goes into 10 and 2 goes into 2. So we can divide this one by 2. So divide by 2, top and bottom. Same here. We can divide this 2 by 2 because 2 goes into 10. If we carry out that simplification, that will give us our final answer, which is 1 over 5. Let's write that again. 1 over 5 plus or minus root 19 over 5. We could put the I in front or in the back. We just put it in the back, I. Okay? Because this 2 and this 10, 2 goes into 10 5 times, and then 2 goes into 10 once. Alright? So the final answer is 1 plus or minus root 19 over 5. So let me just show you the consolation action so you see what happens. So when you divide by 2, this becomes 1, and this becomes 5. That's why we have the 1 over 5 here, and then this becomes 1, and this becomes 5. That's why I have the root 19 over 5 here. So some people write it as with the I in front, some people have the I behind. It doesn't really matter. In this particular case, the correct answer is option number 2. Alright, so that's basically how you solve quadratic equations using the quadratic formula.